Hi everyone. This lecture presentation is just a quick overview of some of the topics that weren't covered in the video you just previously watched. So these are some final notes for how you as an EMS responder are going to handle those cases where you are called to respond to the scene of a HazMat incident. As usual, I'm going to allow you to read the objectives to yourselves. Please feel free to pause the video if you need to. All right, so these are used in fixed facility applications not seen in transport. And a lot of state and local fire codes require that the NFPA 704 system be used at all fixed facility locations within their jurisdiction. The NFPA 704 system is going to actually provide information about the general hazards and the degree of severity for flammability, toxicity, and reactivity. And one important note here is the white diamond at the bottom of your screen. That white diamond contains symbols that can indicate any product-specific hazard. And this system does not identify the product. That's the other thing to remember about this. Your identification of whatever the product is has to be done through one of the many other means that have been described up to this point. When you see the blue diamond, that is referencing the health hazards specifically as part of that NFPA 704 system. And you're going to see a scale of 0 to 4. So 4 being extreme, 0 meaning none. So with the number 4, it's determined to be highly toxic, where you can have just a short-term exposure and it still be considered fatal. And it also requires special protective equipment. So if you come across a fixed facility that has a 4 on that diamond, that 704 NFPA system, then you need to know exactly what you're dealing with because you're going to require special protective equipment. A 3 is layered, or let me try this again. A level 3 is deemed to be a serious or a toxic event where you want to avoid inhalation or skin contact. In cases where you have a number 2, that means that there's a moderate risk, a moderate toxicity risk, and it could be harmful if it is inhaled or absorbed through the skin. And of course, 1 is slightly toxic and it may cause slight irritation. So with 0, it's considered minimal. And just to remember that all chemicals do have some degree of toxicity. So we don't want to take it lightly, even though it does say 0. Now with the red indicates the flammability hazards. So if you have a 4, it means it's extremely flammable and the flash point is actually below 73 degrees Fahrenheit. If you have a system where it shows a 3, this is serious and flammable, and the flash point is somewhere between 73 to 100. A 2 is combustible, meaning it requires moderate heat in order to ignite it, and the flash point is somewhere between 100 to 200 degrees Fahrenheit. And of course, if you see a 1, this is slightly combustible and it's going to require a strong heating source to ignite it, and a 0 is a minimal burn. It's not going to burn under normal conditions. So with the yellow, this is your reactivity hazard. So how reactive is it to the environment? If it has a level 4, it's considered extreme and it's explosive at room temperature. If it's a 3, it's serious and could explode if it's shock or heat under confinement or mixed with water. And a 2 is moderate, so we're looking at something that is unstable and it may react with water. A 1 is slight reactivity, may react if heated or mixed with water, and then minimal is a 0. It does not react with water at all. Now you remember we talked about the white diamonds. If you have a white diamond with the letter W and a line slashed through it, that means that whatever is in that fixed facility is reactive to water. You have to be very aware and very cautious of that. If it has a COR, that means it's corrosive. If it has an OX, it means it's an oxidizer. And of course, if you see the little radiation symbol, then it means it's radioactive. In this section, we're going to address the NFPA 472 standard, where we talk about the competencies for first responders at the awareness level. So we're going to be talking specifically about scene safety. As an awareness level responder, by the time we've gone through this section, you should be able to identify the precautions that first responders should take to protect themselves and others from hazardous materials, describe the precautions to take when treating victims at a hazmat incident, identify potential ignition sources that can be found, identify and describe the routes of entry for human exposure to hazardous materials, list ways that hazardous materials can be harmful to people, the environment, and the property. So we want to make sure that everything we do, we avoid contact with the product, and we attempt to identify the product from a safe distance, from an uphill, upwind approach, and maybe perhaps using binoculars. So regardless of who you are and where you're working, you need to be fully aware of your department's standard operating procedures when it comes to hazardous incidents. And all responding personnel should be fully informed of the action plan for the incident and the hazards at the scene that is specific for that area. So if present, can things like mist, dust, smoke, vapor clouds, can those spread? So these are some things that you want to consider in your mind. You want to weigh the risk and benefit in any response and know the signs and symptoms of product exposure. When it comes to potential ignition sources, it could be anything from lighting equipment, something that causes a chemical reaction, electric motors and controllers, and open flames. So it's always important to take into consideration, stop and really consider what are potential ignition sources in the area, and could it impact the safety and stability of that scene. Some additional sources to consider include fuel-powered equipment, sparks caused by static electricity or friction, or flares, or perhaps heated metal surfaces or internal combustion engines, lightning. It could be your radios, your flashlights can also serve as a potential ignition source. So you always want to be very aware of your surroundings. Inhalation exposure may be a result of contact with hazardous vapors, smoke, fumes, gases, or suspended dusts. So the use of an SCBA can actually prevent this type of exposure, so it's very important for us to consider that, and if we are trained in the proper use of an SCBA. Ingestion, such as eating, drinking, or smoking contaminated products, can lead to the introduction of hazardous materials into the body. So we want to avoid these activities in any type of hazardous material area. And all personnel should be properly deconned before engaging in any of these activities. Other potential routes of entry include injection and absorption. So of course, injection is where we have a puncture or a needle stick. Maybe, we've got some sort of contaminated material and we've had a needle stick from someone who's been contaminated. And then absorption, either through the skin or the eyes, can be introduced into the body. On this slide, you'll see some generalizations of the potential routes of exposure for the different hazard classes. You always want to attempt to determine the exact properties and dangers of the substances involved in the incident, and you can do that by utilizing such resources as an MSDS, a material safety data sheet, or even contacting Chemtrack. The ERG is going to provide some general information regarding the possible routes of entry. So with Class 1, these are explosives, and although the primary hazard in this case are explosions and fragmentation, these materials produce irritating, corrosive, and or toxic gases when burning. And then gases are considered a class 2, and they are most commonly entering the body through inhalation or absorption through the skin as a result of coming in contact with the vapor cloud. And then flammable liquids is class 3. We are inhaling vapors released by the flammable liquid, accidental ingestion of the material, and absorption of the liquid through the skin are all potential routes of entry in this case. Class 4 talks about flammable solids, and if the material is a fine powder that becomes suspended in the air, then inhalation is a possible route of entry. Accidental ingestion of the solid materials, the properties of some flammable solids may allow absorption of dangerous materials through the skin. Your class 5 oxidizers, these types of materials can be inhaled, ingested, or absorbed through the skin, and it depends entirely on the physical state. Your toxic infectious substances are considered class 6, and it's due to the nature of these types of materials it is possible for them to enter the body in any of the 4 methods of potential entry. Radioactive materials suspend in the air and actually can result in inhalation hazard. Accidental ingestion of substance contaminated with radioactive material is also a possibility, and since the skin does not provide adequate protection against most types of radiation, there is danger of absorption. Now, class 8 talks about corrosives, and these types of materials can be inhaled, ingested, and absorbed through the skin, depending on their physical state. And then class 9 is considered a miscellaneous category, and since the exact nature of these substances may initially be unknown, you always want to consider the possibility for multiple routes of entry to exist. As you are well aware, there's a difference between acute versus chronic. Your acute responses to hazardous material are those that are an immediate exposure, such as a single dose occurring during a response at a HazMat scene, whereas chronic is usually a result of low exposures that have been repeated over an extended period of time. So there's a thing called the DECIDE process, and this is just one example of a management system to complement the incident command structure. When one becomes aware of the existence of an emergency, the decision maker is faced with a series of decision events. And to affect or influence the emergency event sequence, decisions must focus on modification of the sequence that would otherwise occur naturally. There are 6 steps that can provide a framework for decision making in a given hazardous materials emergency. These 6 steps include detect a HazMat presence, estimate the likely harm without intervention, choose the response, identify action options, do the best option, and then evaluate your progress. So this is the DECIDE method for hazardous materials emergency decision making. And this quote is really good to kind of keep in the system here. It must be remembered that incident command structure must be used at a HazMat incident. The preceding management technique is intended to help the IC achieve a favorable outcome. So we need to remember that, again, we're approaching from an uphill, upwind environment, if at all possible. And we also need to remember that the awareness level responders are going to be operating in the cold zone only. That's where they're supposed to be located. You've got specialized trained individuals that will enter the hot zone. They'll bring the individuals through the warm zone, and then you all will actually be located to receive those individuals in the cold zone. So your control officer is going to be located in the warm zone along with the decontamination area. So that's going to be your primary point to protect you as the responder from whatever materials they've been in contact with. When it comes to hazardous materials, there's a lot of chemical and physical properties that are commonly reviewed, but we're going to focus a few minutes on a couple of these areas. We're going to talk about the states of matter just as a quick reminder, and then we're going to spend a few minutes on vapor pressure, density, and specific gravity. So again, just as a quick reminder, your hazardous materials will come in one of three forms. They're either going to be present to you in the form of a solid, a liquid, or a gas. And when we talk about vapor pressure, we're talking about the pressure a vapor is actually exerting on the sides of the closed container. So if you have a container that's been damaged in the result of a car wreck, for example, involving a tanker that is carrying some sort of pressurized liquid, then you have concerns that that structure is now weakened and you have that vapor that's exerting the pressure on the sides of the closed container. Do we have to worry about a potential explosion or a leaking hazard at this point with the vapor pressures? And with vapor density, you need to remember that some things are lighter than air and others are heavier. So if you have something that has a vapor density less than 1, then that vapor will rise. Whereas a high vapor density, this is something that has a density that is greater than 1, is actually going to sink to the lowest areas. So this becomes really important in the cases of a HazMat incident. If you have a gas such as chlorine, which has a vapor density of 2.4, which you can see in the picture, that means that all that vapor is going to travel to the lowest points in the lowest settings. So you're going to be looking at culverts, you're going to be looking at sewer areas, you're going to be looking at low-lying areas. If you're in the mountains of West Virginia and you're in a small valley with that chlorine is going to stay within the valley in which it is in. So those are some really important things to consider when you're looking at what has been released into the environment. Is the vapor density less than or greater than 1? And then specific gravity is what applies to liquids. And that's where we talk about specific gravity of water being 1. If you have something like they have on here, I think it's carbon disulfide is what I see in the picture if I'm reading it correctly. This has a specific gravity of 1.3, so it is heavier than water. It's going to go and sink down, whereas gasoline has a 0.6 specific gravity, so it will actually float on the surface of water. So those are also some things to take into account and to take into consideration when you're dealing at a hazardous materials scene. Is this something that's going to drop to the bottom of a liquid, or is it going to span across the surface of the liquid? Regardless, it all goes back to the same thing that we talked about previously. As a hazardous material, a HazMat awareness level individual, you always want to approach the scene from an uphill, upwind approach whenever it is possible. And if the incident is determined to be hazardous, you want to make sure that you isolate the area and deny entry to the scene and protect yourself. So some pros and cons of evacuation versus shelter in place. There's some things that you need to consider when you first arrive on scene. Now we know that the fire department is probably going to make this call, but it may be that you're there first and that you have to start this process before someone higher trained of equal or higher training than you comes to take over. So there's 2 general methods. You're either going to take the public and you're going to move them, you maybe migrate them to someplace else, an evacuation procedure, or you may have them do a shelter in place. So evacuation is to be used whenever it is possible to move people in an efficient manner, and I think that's really important to hone in on. Your shelter in place is more specifically for incidents and environments where it is not possible to move people, and a good example of a shelter in place would be your hospitals and perhaps your nursing facilities until you get enough personnel in to help assist in the movement of those individuals. So you've got either a stay and play or a load and go kind of thought process here. You're either going to have those people evacuated or you're going to have them shelter in place. So that's going to be very incident specific, and there's going to be lots of factors to take into consideration when you make this decision. And again, use that DECIDE protocol that we talked about earlier. That may help you. And if you have any questions about this lecture, please let me know, because at this point we're done. If you have anything that comes up, I am absolutely not the master on HazMat. I have been trained up to the operations level, but I am not a specialist or a technician. So if you have something specific and I can't answer it, we will find someone who can. And as always, you can always look to James Hill, who originally, both him and Fred worked together to create this presentation. So they may be able to guide you with some more detail if you have any questions or concerns. But thank you so much for your time. Have a great day, and we'll talk to you soon.